Hello, world. Hello.
So quick.
Yes, it was just a single click. Well, I already had the logo running in the background, so I just needed
Yeah,
to
I saw
switch
that.
scenes.
Yeah,
I
I
cheat.
got an email. Yeah.
I
Um,
believe in cheating when it comes to how we run these things.
it's not
So,
cheating. Are you kidding? Boom. It's a funny time, and here we are exactly at the appointed time doing our episode. We more people asked for. I guess doing our show on time on the Friday when we said we were going to.
well,
That's the more that people could ask for.
sometimes weather, life, and allergy meds
Yeah.
all convolve to kill your brain. And when I recorded Daily Space on Friday, I don't know how many of you watched, but my brain, like, I couldn't read. And I figured if I can't read a scripted show,
Yeah. Yeah.
what hope do I have for Astronomy Cast?
Well, and we were talking about this before that, every spring I always go through this phase where I'm like, oh, what's wrong with me? Like, am I having a brain tumor? Like, my vision isn't working so great. My brain is really foggy. What's going on? And then I always remember, oh yeah, it's allergies.
Right,
And that's and
right.
that's when we start taking the Claritins and everything gets a lot better.
I can't take Claritin. It makes my heart skip beats and do other bad things.
Yeah, yeah,
So I'm strictly a Zyrtec girl.
yeah. No, I was just telling Pamela in the U.S. Sudafed is, I guess it makes meth or something, and so people,
Yeah,
it's a heavily controlled substance. Like I tried to go buy someone down in the States, and
it's hard.
I was not allowed. Right?
Oh,
Yeah,
because you're
not
Canadian.
an American, so no. Um, when I just like went into a pharmacy, I was like, "Can I buy some allergy medicine, please?" And they're like, no, but here, do what you want. Go in, grab them, take them.
Can't you also get Tylenol 3 there?
No, not over the
Okay,
counter.
that's just in the UK then.
Yeah, yeah,
Yeah,
yeah.
no, I can't get it in Oregon. It varies state to state how strict the rules are. And when
Mm,
I was in Oregon, because it's me, I was allergic to everything, and
yeah.
I could get no rescue
You can't even see the ground here. Everything's covered in snow. How can the allergies have already started? It's crazy.
because the trees don't care.
The tree. Carla said the exact same thing. Yeah, I mean we're surrounded by lots and lots of trees, so I guess it's trees. Fine.
Well,
I bought a chainsaw, so those trees better get in line.
I went outside a week or two ago to just like survey the yard and pick up all the dog toys to put through the washing machine because dogs slip out the door carrying stuffed toys periodically. And my strawberry plants and raspberries and blackberries were like, we shall have leaves now. And I'm like, you stupid plants, it's January. And they have now been snowed on. And they're still sitting there going, hi, we shall have leaves now.
Right, right.
And so I think I'm going to have to get my seedlings started in the next couple of weeks because climate change.
The
Climate
weird
change.
thing is January is the time to plant peas. Like if you want like snap peas, then and now's the time. They love to be
Really?
planted in January. Yeah, yeah. And then they're growing by March, April. You're eating peas off your plants. But it's so incomprehensible to think that those times will ever return. Like this is the new normal, is just this horrible snowy landscape. This is all I know now is
Oh,
just
man.
the glaciation of my life. Um,
Yeah, I don't quite have that going on. We got 2 inches.
yeah. Oh, that's adorable.
It's
Um,
they gave us a winter weather warning and
yeah. Well, your winter weather warnings tend to come in swirling.
well,
So,
yeah.
so did you see the videos
The
of the
Tonga
eruption, the Tonga
eruption.
eruption? Yeah.
Yeah, it's like I would be super excited except for the island of Tonga is underneath all of that.
Well, no, it wasn't the actual island.
No,
It
no,
was
but
a.
it's underneath that cloud. Some of the map overlays they've
Oh,
done,
yeah,
that
yeah,
that amazing eruption in the satellite images about uh, a little more than halfway out from the center of that is the distance to Tonga. And there's only one ocean line into Tonga, and apparently it's damaged or worse because there's no longer any open communications to Tongo. And various folks who have satellite phones have managed to, like the BBC, not the BBC, the British Embassy, the New Zealand Embassy have been getting some information out. But apparently there was a massive tsunami and it looks like a moonscape from all of the ash.
All the ash, yeah.
But I haven't been able to find any photos coming out yet.
I saw the one video of them showing the tsunami coming in.
Oh, I haven't. The tsunami coming in?
Mm-hmm. Yeah. Yeah. Some people standing on the house and the tsunami was rising all around them. But it didn't look too bad.
Are you sure that that was from this eruption?
I think so, but
okay.
Maybe.
It's the internet.
Yeah. Yeah, true. And The Expanse is over.
I know. I now that it's over, I can binge watch the season.
It's so good.
Mourn
oh,
that it's
so
over.
Good.
Did it end the way it needed to end, or do I need to not watch the last 20 minutes?
Oh no! It resolved things nicely, but it's only partway through the book series. But it's sort of a good partway point, says Carla, who's read them all.
Okay.
So. All right, we've killed enough time. People have had their 5 minutes. Let's get cracking.
All right, I am pressing the record button. Oh, I need to tell it what episode this is. This is 627. Whoa, I named it 6,237 because mistakes were made.
Well, no, that'll be the future. That just shows that
we will be dead at that point.
No, you maybe, not me. Robot bodies.
It's taken us 15 years to do 600 episodes.
Mm-hmm.
That implies it will take 150 years to do.
It seems feasible. Tell you what. If we live 150 years, we'll keep doing Astronomy Cast.
We'll need to live to 190 years to do that.
Yeah. Yes.
All right.
Are you just looking for a way to not do Astronomy Cast? Is this what this is? You're just looking for a way
I just kind of don't want to see the ultimate end of where climate change is going. But that's a personal problem.
Right. Yeah.
Okay. I'm pressing record. I'm pressing the other record.
Press record.
You're recording.
Okay, here we go. Astronomy Cast, episode 627, Mercury Revisited. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain, publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. We have what you would refer to as an adorable 2 inches of snow, and it brings me joy.
That's awesome. So I want to begin this episode of Astronomy Cast with a shameless self-promotion for the Patreons that are associated with all of the projects that we do. So Pamela is going to talk about the Patreon at the end of this episode for Astronomy Cast, and you should definitely be a part of that, as well as the one they do for CosmoQuest. But if you're a regular reader of Universe Today, you might not know that if you join my Patreon for a one-time, just like one amount of money, any amount at all, I will remove all the ads from Universe Today for you forever. So you will never see another ad. Even if you cancel your Patreon immediately, you will still have no ads for the rest of your life, as long as that WordPress login exists. So plus you get other cool stuff, advanced access to all the videos and behind the scenes stuff that we're doing and lots of other cool projects that we're working on. But that's one of the main ones. You come to our website, because I have a lot of people who become my patron and they're like, yeah, I found out about you because of Astronomy Cast. So, hey, people of Astronomy Cast, I run Universe Today. If you go to that website and you don't want the ads, you can remove them all for the rest of your life. All right, Let's get into the episode.
All right.
It's been about 1,000 years since we last looked at Mercury. So we figured it's time for an update. What new things have we learned about Mercury, or even new questions? Fortunately, there's a mission on the way to help get some answers. And we'll talk about it in a second, but it's time for a break. And we're back. So, Pamela, Mercury was part of the solar system review that we did, the tour through the solar system, as one of the earliest episodes, I think back in the 20s or 30s. So definitely is a good time to take another look at Mercury. You set aside Mercury from the other terrestrial planets last week. Why?
Well, it doesn't behave like any of them. It doesn't seem to have been active since it was formed 4.6 billion years ago. It had mild volcanism for a while. Other than that, it's basically oozed when struck hard enough to form mare like the moon has. And if we did an episode on the moon and Mercury together, that I'd be happy with. But then it also has these weird things like it is the densest planet in our solar system. Dwarf or non-dwarf, it's simply the densest. And it behaves in ways that are similar to some of Jupiter's moons insofar as it's still got a liquid core due to tidal heating. It's just getting tidally heated from the sun. And all these things are weird.
So Mercury is less dense than the Earth.
No.
Mercury is 5.43 grams per centimeter cubed, and Earth is 5.51 grams per centimeter cubed.
Hold on, everyone. I'm having a moment of that doesn't match with what I thought I had read.
So, from what I understand, it's because the Earth has more mass, and it's essentially mashing the stuff more densely because it just has more gravity.
Yeah, 5.5 versus 5.4. It's the uncompressed density is the highest.
Right. So you could say something like, I guess, if it was like it's incredibly dense, and if it was the same mass as the Earth, it would be way denser than Earth because it's mostly metal and rock. So you can do it however you want, but that would
let me go back and correct that. Yes.
The angry email.
So let me clarify. It's not the densest.
Do you want to just ask the question again and we can just go right into it? All right.
Yes.
And I forgot to mention. So go to patreon.com/universe today. I forgot to mention how people can join the Patreon. Okay. So Rich can throw that in there. Perfect. All right. So last week we talked about the various terrestrial planets, and you wanted me to hold off talking about Mercury until this week because it is actually quite different from the rest of the terrestrial planets. Why?
Well,
what's going on?
It's more like a moon in terms of it doesn't have an atmosphere that leads to weathering. It had volcanism in the far distant past, maybe 4.6 billion years ago when it formed, but that volcanism didn't stick around. And the mare seas that we see on it are in many ways like the mare seas that we see on the moon, where they were created when massive impacts caused the liquid internal bits to leak out onto the surface. And that liquid on the inside is due to tidal heating, which is more like we'd expect with a moon of Jupiter. And none of this is how a planet behaves. And then on top of all of that, if you were able to just uncompress all the worlds and let them exist without being squished by their own self-gravity, it would be the densest object around due to its high metal content. And Earth is the only thing that, when you let things get squished down by gravity, is denser. And we know we lost all of our light stuff to the moon in a collision in the past. So that just makes Mercury even more weird.
Right. That it is like super close to the sun, baked by the solar radiation, the solar wind, lost a lot of its volatiles. There's some really bizarre shapes on its surface that I'm sure we'll go into that are fairly newly discovered. It's such a crazy world that, I mean, it's like smaller than some of the moons.
Oh,
right?
Yeah.
Right? Yeah. Weird.
Titan's bigger, Ganymede's bigger.
Yeah.
And it's just weird. It's just weird.
So I guess one thing that I think is really important is that when last we talked, it was, again, I said 1,000 years ago because I was too lazy to actually look up the date that we talked about it last. But it had to have been before 2011 when NASA's Messenger spacecraft arrived at Mercury and did a lot of its work.
Yes.
So what did we learn about Mercury from Messenger?
Well, it's a whole lot more cratered than we imagined, and those craters aren't even majority direct impact, some researchers think. Because Mercury is such a solid object that when you hit it with a big rock, it tosses out chunks that go form additional secondary craters. And trying
Wow.
to untangle those primary craters from those secondary craters is a challenge. The other thing that we learned is, I mean, it wasn't the first spacecraft to go there. It had previously been visited by Mariner 10, but the details with which we saw it allowed us to understand that there's things like the massive Chloris Basin on one side and the weird terrain. They actually refer to it as the weird terrain. It's a
The
lot like
chaotic
Pluto's.
terrain?
Yeah.
Yeah, yeah.
On the other side. And this partnering of massive crater and weird surface features is thought to either be due to the shock waves rebounding around the world and tossing up the terrain at the antipode, or some papers even think that it's from everything getting flung up and landing at the antipode. And of course, somewhere in between is possible. And so you have this world that has really been knocked around a lot. It's had a hard life. And all of that is apparent in the never getting weathered, never getting filled in with lava surface that we get to explore.
And this, I mentioned this chaotic terrain. I mean, one of the things really, because Mercury is so small and has relatively low mass compared to Earth, Venus, etc., it has cooled down quite a bit, despite being next to the sun. And what effect has that cooling down had to the planet?
Well, this is one of those things that we look at the moon and Mercury, and again, they're so similar. They both have what's called lobate scarps. And what has happened is, and it's the most ridiculous term. I don't know why I find it so ridiculous, but even you snorted at the name.
Yeah, awesome.
As the inside
Sorry,
of the
that was
world,
a snort of appreciation.
it's also just a cute name. Let's admit that.
Yeah.
So you start out with larger, hot object of molten goodness. The outer surface cools first, even under the influence of the sun. And then as the inner parts cool, they shrink. And you end up with this outer shell that is now bigger than the inner world. And it goes shrink. And as it compresses and crumples down, it creates these faulting areas where the land can slide up on top of each other. We have lobate scarps here on Earth as well, but the ones on the moon are the ones that are indistinguishable in images from the ones on Mercury. And that's just kind of cool.
I'm sort of imagining this planet crumpling in on itself, crunching smaller and smaller, and these big cracks opening up across its surface and jumbled up terrain as it's trying to process this. Not to mention getting hammered by various meteorites and all the comets that are drawn into the sun's gravity. So I think you're right.
Yeah, compressionally it has thrust faults, lobate scarps, wrinkle ridges. So it starts out all wrinkled up, and then you just keep throwing things at it. Even Comet Encke has thrown bits and pieces at its surface. And I just love that we can blame one specific comet for at least some of the damage that has occurred.
All right, we're going to keep talking about Mercury in a second, but it's time for another break. And we're back. We should talk about the atmosphere of Mercury.
Yes.
Which is a phrase that I'm sure people never thought they would say.
I kind of feel like atmosphere is too strong a phrase. Exosphere, I think that's again the same word that we use for the moon. So Mercury has a magnetic field. It's significantly weaker than the Earth's magnetic field, but it is sufficient to generally protect Mercury from the solar wind. This magnetic field comes from Mercury has a highly elongated orbit, and because of this combination of the squished orbit, the most squished in the solar system for a planet, as it goes around the sun, it isn't tidally locked to the sun the way the moon is to the Earth, so that the exact same size is always facing the sun. That would have happened if it had a circular orbit. But because it has this squished orbit, you end up with these weird moment arms inside of it, so that for every 2 times it goes around the sun, it ends up experiencing 3 days. And this constant squishing and unsquishing with its elliptical orbit leads to it continuing to have a molten core, lots of metals, and it still has a magnetic field. That magnetic field means that various materials coming off of its surface get to stay put for a little while, but they do end up streaming behind it, so that in certain solar images, you see this tail of particles constantly streaming off of Mercury. So there's this 1-2 situation of magnetic field allows things to hang out for a while. You have cosmic rays coming in from the sun that are knocking ions off the surface of Mercury, and all of this ends up eventually leaking ever so slowly out behind it to form a tail.
It just thinking about a planet having a tail,
Yeah,
which is such a great idea. So how did Messenger die?
we crashed it into Mercury. Because of course we did. It's what we do with things. We crash them.
Right. Did you see, I saw a tweet or an animation or something where someone was crashing. They were talking about crashing Cassini into Jupiter. And in the end, they came together
Saturn.
for a hug. Saturn. That's right. Sorry. Yeah. It was a
We
cartoon. They
plunged
crashed
Galileo into Jupiter, Cassini
they
into
crashed
the sun.
That's right. Yeah,
Saturn.
they crashed Cassini into Saturn, and the animation was the spacecraft just stopped right at the last second, and Cassini and Saturn had a hug, because all good missions end in a hug, which I thought was very cute. But Messenger had its litho breaking
Yeah.
with Mercury.
Yeah, that was a thing. It got a few good years in there. It returned a whole lot of really solid images. And some of its instruments even allowed us to get hints at its surface, which is really the only way we're ever going to totally figure out how this weird world formed so close to the sun. And there's a lot of different theories. And it's only BepiColombo that hopefully is eventually going to help us untangle exactly which one of these theories is correct.
All right, we're going to talk about BepiColombo in a second, but it's time for another break. And we're back. Now, before we actually started the show, I think before we even started recording, you were just going on about the questions that you had about Mercury. So why don't we kind of interleave the questions that you have about it with the reality that a spacecraft is going back to Mercury to try and answer some of these questions?
So my biggest question is why, and someone can probably explain this to me, I just haven't found the answer yet, because people don't publish enough on why things aren't the case. So we know from exoplanet studies that there are a lot more mini Neptunes than just about anything else out there. We know that there are a lot of worlds that migrate in towards their sun and suffer greatly, eventually losing their atmosphere. And looking at Mercury, we see a world that is much denser, uncompressed than it should be. And so what I would love someone to explain to me is, how do we know that it's not a mini Neptune that had its atmosphere removed in the early days of the solar system?
So we see that. I mean, we see exoplanets
systems
now with, they're clearly being dismantled by the gas parts are being dismantled by the star.
Yeah.
So is that a possibility?
Well, this is what I don't know, because trying to Google why is something not the case has failed me. So I'm hoping someone has thought on this, has published on
Yeah.
their other theories, and will someday
let's-
hear this and explain to me the other theories that people have published.
Right. Well, let's talk about BepiColombo though. This is
Okay.
So who is sending this mission?
This is primarily a European space agency and JAXA working together. It's actually 2 spacecraft that are flying together and will become 2 spacecraft once they get to Mercury.
Right. And it's a long journey. We've talked about this in the past that
Yeah.
that Mercury is like the hardest planet to reach in the solar system. Because
Yeah.
you've got to get rid of all the Earth's orbital velocity to get there. So it's taking a very tortured journey.
This spacecraft was named in 1999. It's been years since it launched. I don't even remember its launch anymore. And it finally gets there in 2025.
I launched 4-ish years ago in October 2018.
Yeah, it launched years ago.
Yeah.
And so that's a 7-year journey basically to get to a world that in the grand scheme of things isn't that far away, but the problem is you have to match its orbit just right or you fall into the sun. And while you could do like your standard Helmholtz orbital transfer like we do to Mars, the problem is that the velocity close into the sun on a Helmholtz orbit that has the Earth at the farthest point from the sun and Mercury is the nearest point to the sun, you'd be going entirely the wrong velocity to be able to go into orbit without lots and lots of fuel being required.
Right.
So you have to figure out how to match speeds another way.
Right. And the way you do that is I guess you give, because we talked about gravity assist in the past and how you are stealing orbital momentum from from the giant planets as you go past them to speed yourself up. And you're doing the opposite. You're giving them a little bit of orbital momentum to change your trajectory to get closer and closer into the sun, which is kind of crazy.
So getting there is hard. And the thing is that by the time any mission gets to Mercury, we are going to have questions that we can't answer with the instrumentation that's on board because science has advanced, instruments have advanced, and it's highly frustrating. But hopefully BepiColombo, with its ability to measure the chemistry of the surface and so many other things about the internal structure and the magnetic field, hopefully it's going to help us understand exactly how this weird world ended up forming. And right now, one of the primary ideas is it had a massive collision, not unlike the Earth had, that knocked all the lightweight material off of it, and that it actually started out more than 2 times the mass of Earth. But the other theory, there's a variety of theories. The other theory to look at is during the solar nebula, anything lighter than what Mercury is currently made of simply was blasted away by the solar nebula. And the way we can start to separate these ideas is by looking at the surface composition. And with MESSENGER, we were finding higher potassium and sulfur levels, which seem to make sense for the giant impact hypothesis. So yeah, imagine losing that much mass in a collision and still being left behind.
One of the great interests of exploring the moon is the possibility, and I guess now almost the certainty, that there are deposits of water at the South Pole and the North Pole of the moon. Is there something similar on Mercury? Are there permanently shadowed craters on Mercury?
Yeah. And making it even more interesting, Mercury is tilted less than a degree off of its rotational, off of the orbit around the sun. And so the sun never gets more than a few arc minutes above the horizon. the horizon. So you don't need very much of a crater to have a permanently shattered region. And so there's water that has been found through radar returns, at least we believe it's water found through radar returns within those permanently shattered regions. And the temperatures are completely reasonable for machinery to exist at the poles. And some science fiction writers, like Kim Stanley Robinson comes to mind, have even imagined, because its rotation rate is so slow, that you could have essentially domed cities on massive tracks that simply moved just out of the sunlight as the world rotated to constantly stay at just the right temperature so they were never too hot or too cold. And Mercury...
That sounds crazy.
Yeah, it's a tantalizing world for future technologies we do not have.
Right. But the same ideas that are being proposed about going and setting up some kind of operation at the moon's south pole,
Yeah.
you could do something almost the identical situation at Mercury. It might even be a little bit easier because Mercury, it doesn't have as much, what is it? Eccentricity, which is the one that it rises and goes above and below the plane of the ecliptic. I forget. Anyway, it's
tilted more to the plane of the ecliptic, actually, than any of the other worlds. So
Right.
it's tilted about 8 degrees to the ecliptic. With the moon, it has a weird tilt because it's going around the equator of the Earth. It's going around the ecliptic in the sky, and then the Earth is tilted. So there's just a lot of weirdness going on.
Yeah, a whole bunch of added trigonometry going on there.
Yeah.
So I guess BepiColombo arrives Mercury 2025.
Yes.
As you said, 2 spacecraft. It has a Japanese spacecraft and the main BepiColombo built by ESA. They're going to separate and then explore Mercury together.
Yes. And it's really an interesting new future that we're looking at, where we have multiple missions simultaneously going to different worlds. We're looking at a future where we're going to have 3 main and then a bunch of smaller satellites all going to Venus, where we have these 2 different missions going to Mercury. We keep throwing new things at Mars every proper alignment of the orbits. And this combination offers both the ability for the 2 missions to confirm each other's results, something that's been extremely important at Mars, where we've needed to confirm things like the methane results that were highly controversial. So we get the ability to confirm, and we also, well, if one of them fails, hopefully the other one will still keep going. So there's this redundancy in our ability to get data. It's an exciting day anytime we can get just one spacecraft to a world, but to have this new era of multiple spacecrafts is well, here's hoping that we have funding to support enough scientists to get everything we can out of all that data.
Yeah, it does feel like we're just getting a more and more established presence out there in space when you add up all the spacecraft and all the different targets that they're at right now. It's pretty great. All right. Well, I'm sure we'll come back around in 2025 and talk about the mission itself. Till then, of course, I think we're just going to wait.
It remains dead to us.
Right. All right. Well, thank you, Pamela.
Thank you. And thank you to all of our patrons out there who are, well, allowing us to keep everything going, to pay Rich, Allie, Nancy, to keep us on the straight and narrow, to have Beth out there promoting everything we do. You're doing awesome things. And we just want to thank some of you by name. And this week we're going to thank Zero Chill, William E. Krause, Frank Stewart, Daniel Lossley, Jim Schooler, Benjamin Carrier, John Drake, Ganesh Shwarmanathan, Bob Zatsky, Thomas Sepstrup, Burry Gowen, Jordan Young, Stephen Veit, Kevin Lyle, Jeanette Wink, Mountain Goat, Gerhard Schwarzer, Andrew Poelstra, Brian Cagle, Venkatesh Chary, Aurora Lipper, David Truog, David, TheGiantNothing. I love that username. Will Hamilton, Ronald McCoy, Jean-Francois Rogette, Cacao Seraph, William Krause, Bill Hamilton, Robert Plasma, Laura Kettleson, Joshua Pearson, Les Howard, Jack Mudge, Joe Holstein, Gordon Dewis, Helga Bjorkog, Frank Tippin, Alexis, Adam Annis Brown, Neuter Dude, William Backer, Wanderer M101, William Andrews, Andy Cowley, Jeff Collins, Harold Bargenhagen, I don't know, David Gates, Scott Bieber, Matthew Hortzman, and Nikki Lynch. And as always, if you would like me to pronounce your name correctly, please just spell it phonetically in Patreon. Stephen, I saw that you changed your username to Stephen Veit. It rhymes with right, and that brought me so much joy. So much
That's
joy.
awesome. All right. Thanks, everyone. We'll see you next week.
Thank you. And then they saved. All right. Let's drop this in the correct folder. All right, so whether you're watching on Twitch, where I'll be looking, or YouTube, where Fraser will be looking, get your questions in, and we will do our best to answer them as soon as we have all the files where they need to go, so the wonderful humans who make us look good can, make us look good.
That didn't work.
What didn't work?
My upload.
Oh, no.
It's okay. Be all right.
All right.
Okay, it's uploading. To the core of a planet.
Yes. Yes. This is why I want someone to explain to me why it could not be like a former mini Neptune.
Mm-hmm.
Yes.
I don't think someone can explain them as their atmospheres are being stripped away. Like this is how you get Mercury's, maybe. 5,000 exoplanets now, almost.
Yeah.
That all the different configurations, stuff that's bigger, stuff that's smaller, stuff that's rings, different shapes, could be like you've got the pressure from the sun, you've got raw materials, you've got the orbital resonances of the various planets, you've got the rings, the gaps in the disks with them that we see today.
Well,
and
what also
it could
gets
very well
me...
be that it's just...
Go ahead. With small planet and large planet sized objects, that includes, start with 2x or more the number of planets, fling them about violent, many out banished the middle of solar.
Marina asks, what do you think of the idea that Jupiter protects Earth from asteroids?
Something out of the solar system as into the inner, or into the out. And yeah, it just flings things.
When you
it's
think
chaotic
about
neutral.
The asteroid belt, the asteroid belt cannot form because Jupiter's gravitational interaction just keeps jostling all the objects in the asteroid belt. And
the asteroid belt could
constantly
form, it could not
pushing
form
objects.
a planet.
Sure, yeah. And the asteroid belt could not form one single object because Jupiter keeps it all jumbled. And Jupiter is constantly pushing, overflowing the asteroid belt objects out to inward. And so the near-Earth objects that hit the Earth are constantly being replenished by Jupiter's gravity. That it is a endless resource of space rocks. And that if you removed all the near-Earth objects and you came back a few million years later, there would be a whole new set of near-Earth objects potentially hitting the Earth. So, no, Jupiter's no friend of ours.
What gets me is how so many things get me, apparently. We are very biased in our understanding by the safety that we have experienced in our lifetimes. Sure, there was Chelyabinsk But in the grand scheme of things, up until this week, we hadn't had a truly catastrophic volcanic eruption. And so we kind of stopped paying attention. We haven't had a truly catastrophic collision, so we make fun of them in movies. And I wonder how much living during a seemingly calm period in our solar system's history causes us to not think through possibilities for solar system evolution and formation.
Yeah. Yep. That's it. I don't see any questions here. Do you have any questions on Twitch?
There was a question about how we knew that Comet Encke interacted with Mercury. And Comet Encke is a family of objects with the main Comet Encke body and then other chunks that form the same orbital family that interrupts Mercury's orbit. So there's orbital dynamics telling us the two have had bad days together.
Right. That's it. That's all. Those are all the questions that I see. So,
all right. So this is your reminder, if you are a patron, that we have office hours starting in 15 minutes. I'm going to go find a warmer room in my house. And if you are not yet a patron, I'm going to be emailing that link out. So go join. I think it's either the $3 or the $5 level. And this is your chance to talk randomness and ask me any science questions you want that I may or may not have answers to.
Bring James Webb questions. She loves those.
No.
All right. Cool. Let's wrap this up so you can prepare for the office hours.
Okay. Sounds great. So,
right. Well, thanks, everyone. Thanks to everyone watching us on YouTube and on Twitch. Thanks to Nancy Graziano and the rest of the moderators for keeping organized. And thank you, Pamela. We'll see you
Fraser.
next week.
Okay. Bye-bye.
Have fun with office hours. Bye.
Yes.